हेलो स्टूडेंट। वेलकम बैक टू एजे क्लासेस। तो आज हम पढ़ने जा रहे हैं द मोस्ट इम्पोर्टेंट टॉपिक ऑफ ऑर्गेनिक केमिस्ट्री, दैट इज द सम बेसिक कॉन्सेप्ट ऑफ ऑर्गेनिक केमिस्ट्री एंड द स्टार्टिंग इज द स्ट्रक्चर एंड द बॉन्डिंग. So the basic concept of organic chemistry starts from the structure and bonding, and this is the first chapter of the BSc second semester organic unit. So going to the chapter, the first of all, the structure and bonding. This is the first chapter. Okay, so here see the properties of organic chemistry. The properties of organic chemistry compounds can be correlated to their structures. That means the structures of organic chemistry compounds depend upon the structure. Means the property of organic chemistry compounds that can be correlated to their structure. So we can correlate the structure with the properties of chemical compounds. Then organic compounds essentially contain carbon and hydrogen atom. You know that all the mainly the carbon and hydrogen are the main equipments, are the main compounds of the organic compounds, and occasionally heteroatoms such as oxygen, nitrogen, sulfur, phosphorus and halogens may also be present. So mainly carbon and hydrogens are present in the organic compounds, but in some cases the other compounds such as oxygen, nitrogen, sulfur, phosphorus and halogens are also present. The various atoms in organic molecules are held together by covalent bonds. Okay, the various bonds which may be single, double, you can take the example of, methane. This is the organic compound here in which one carbon atom is related with 4 hydrogen atoms, that is CH4. Here that is one hydrogen, here this is also one hydrogen present, here also one hydrogen present, and here also one hydrogen is present. So in this CH4 there are the bonds between carbon and hydrogens, and here that is the together held by covalent bonds. This bond in between carbon and hydrogen, that is the covalent bond, and this is also a covalent bond, and this is also a covalent bond present in the molecules. Here it is present the only single bond, but if you take as this is a alkane, if you take the examples of alkene and alkyne, that will be presence of the double bonds and the triple bonds. So then after that the covalent bond formation. Okay, then after that the covalent bond formation. So the covalent bond is formed by the overlapping of atomic orbitals. So simply covalent bonds are formed by the overlapping of orbitals. So by the overlapping of orbitals, the covalent bonds are formed. So there are different types of the formation of covalent bond. That is, one is the overlapping may be different types. That is two center one electron. That means here there are two compounds. One is A and the another is B. In such cases, in A there is one electron present, but in B there will be no electron present. So this is two center वन इलेक्ट्रॉन टाइप ऑफ कोवैलेंट बॉन्ड फॉर्मेशन. ये भी हो सकता है कि हमारा दो जो मॉलिक्यूल है ए एंड बी, उनका बीच में ए में दो इलेक्ट्रॉन हो, बी में कोई इलेक्ट्रॉन ना हो. ऐसा भी हो सकता है. उसका कहा जाता है टू सेंटर टू इलेक्ट्रॉन. और ऐसा भी हो सकता है वहाँ पे दो तीन एटम हो, ए सी एंड बी, एंड वहाँ पे सी में हो दो इलेक्ट्रॉन, बट ए एंड बी में कोई इलेक्ट्रॉन ना हो. So this case will come as the three center two electron type of covalent bond formation. So after that we will go to the s orbitals. So you will know the s orbital has the shape that is spherical. तो हमें पता है कि एस ऑर्बिटल का शेप है spherical. So the s orbital, the shape of s orbital is spherical. So remember one thing, the very important point, this one. Remember, if the shape is spherical, then there is spherical distribution of charge cloud. See here, if the shape is spherical, then that means there will be the charges are displaced in all over the spherical distribution of the charges will be held inside the sphere. So this will tends to the spherical distribution of charge. That means if the structure is sphere, then the distribution charge is also this spherical or not. अगर हमारा जो सेफ अगर स्पेरिकल होगा तो चार्ज डिस्ट्रीब्यूशन भी स्पेरिकल होगा. अगर यहाँ पे सेफ ऐसे सर्कल हुआ तो चार्ज डिस्ट्रीब्यूशन ऑब्वियसली यहाँ पे एक चार्ज होगा, यहाँ पे एक चार्ज होगा, यहाँ पे एक चार्ज होगा, यहाँ पे एक चार्ज होगा. तो चार्ज डिस्ट्रीब्यूशन इज ऑल्सो स्पेरिकल होगा. अगर एटम अगर स्पेरिकल होगा तो यहाँ पे से यहाँ पे से यहाँ पे से ऐसे चारों तरफ इसे spherical distribution of charge होगा. So this is s orbital. Then after moving to the next page, so after that, if the distribution of cloud is spherical, then the charge distribution is symmetrical. We learned that if in the s orbital, that is it has spherical shape. If it is spherical shape, then it has symmetrical charge distribution. If it has symmetrical charge distribution, that has spherical charge distribution, and if it has spherical charge distribution, that means it has symmetrical charge distribution. That will be the charge distribution will be symmetrical inside the sphere. If there is symmetrical distribution of charge, thus the attraction of the nucleus is high. If there will be the symmetrical charge distribution, then the attraction of the nucleus. Remember one thing, if the charge distribution is symmetrical, then attraction of the nucleus is high. So remember, if the shape is spherical, then that tends to the spherical distribution of charge. If it is spherical distribution of charge, then this tends to the symmetrical charge distribution. If there is the symmetrical charge distribution, that means the attraction of the nucleus is very high. So after that, there is a concept of penetration and shielding. Penetration shielding, they are the polyelectronic and many orbital phenomena. Penetration and shielding दो दोनों ही दो अलग कंसेप्ट है, दोनों से रिलेटेड है, बट दोनों का कंसेप्ट अलग है. पहले पेनेट्रेशन होता है, उसके बाद शील्डिंग होता है. सो पेनेट्रेशन क्या है? When electron density cloud of outer orbital occupy region of inner orbital is called penetration. तो जब हमारा एक ऑर्बिटल यहाँ पे एक 1s ऑर्बिटल है और एक 2s ऑर्बिटल है. Let here it is a 1s orbital and this is a 2s, orbital. So this is a 1s orbital and this is a 2s orbital. If there is 1s orbital, remember let this is r1 and this length was r2. If this length was r2, that is 1s orbital and it is 2s orbital. So then and after the concept of penetration arises if we add an electron to the 1s orbital. अगर हम 1s orbital को एक इलेक्ट्रॉन देंगे, so that the electron cloud of the 1s orbital should be increased if there is the increase of electron in 1s, so that the attraction of the nucleus to the 1s orbital will be more, so that the 1s orbital will move, the 1s orbital will move from this region to this much. Okay, so this is the change in the position of 1s orbital, and similarly the 2s will be attracted more by the nucleus. But here see that some parts of the 1s orbital that after the penetration goes into the 2s orbital. That is known as the concept of penetration. Penetration means some parts of an orbit intermix or orbiter goes to the another orbit, that is known as the penetration. Then thereafter the similar thing, let us consider two orbitals, 1s 2s. Let an electron is added to it, then the size of 1s decreases due to strong attraction of the nucleus. Similarly, the size of 2s decreases. In this process, some electrons density of 1s was occupied by the 2s. That means some electron density of one orbital is occupied. अगर एक ऑर्बिटल का इलेक्ट्रॉन डेंसिटी दूसरे ऑर्बिटल को अगर ऑक्युपाई करा जाएगा, उस फेनोमेनन को कहा जाएगा पेनिट्रेशन. And the shielding, shielding is the consequence of penetration. So पहले रिमेंबर एक चीज, पहले पेनेट्रेशन होता है, उसके बाद सील्डिंग होता है. तो यहाँ पे एक कंसिडर करो, ये है न्यूक्लियस, लेट यहाँ पे 2s2, यहाँ पे अर्ली पोजीशन दोनों का सेम था. बट आफ्टर द पेनेट्रेशन इफ वन इलेक्ट्रॉन एडेस, द 2s orbital will be penetrate inside. This will be the penetration, and due to this penetration of 2s orbital, this will shield the attraction and the 2p will be moved to far. Okay, so this is the shielding. Shielding means the if the electron cloud in the 2s will be increased if one electron is added and its size decreases. So the shielding power also increases. So this is the consequence of penetration is the shielding. Remember one thing, at first the penetration occurs and after that the shielding occurs. So remember one thing, chemical species are of two types. One is monoelectronic species and the another is polyelectronic species. So monoelectronic species means they contain only one electron. The monoelectronic species means it contains only one electron, and the polyelectronic species means the number of electron is should be greater than one. So monoelectronic species no penetration and shielding effect, because and earlier I have told that the penetration and shielding are many orbital polyelectronic effect. So as there is only one electron, the orbital will be one and the electron will be one. So in this case the penetration will not be shown, and here both the penetration and shielding shown, because as electron greater than one, then it will be polyelectronic and mono orbital also. So in this case no loss of degeneracy of cell, as there is no shielding and penetration, that means there will be no loss in the degeneracy of cell. And here as penetration and shielding both are occurred, so there will be degeneracy of cells. And here energy of subcells will be equal. In monoelectronic species the energy of subcells, that means the energy of Ns is equal to Np is equal to Nd. But here as shielding and penetration occurs, the energy is not equal, that is the Ns is less than Np, is less than Nd. So this is all about the penetration, shielding and the basic concept. इन द नेक्स्ट क्लास विल डिस्कस अबाउट द मोर थिंग्स. अगर आपको वीडियो अच्छा लगता है तो लाइक कीजिए, चैनल पर नए तो सब्सक्राइब करके बेल वाला आइकन को प्रेस कर दीजिए.